Alright, we're putting on a new 4-pin connector. The black wire is ground, and we're going to put a little hook in it at the moment. And we're going to go through the shield, which we want to go to the case. And we also want it to go to pin 4 of the 4-pin connector. Now that's important, because pin 1 is plus 24 volts, and you don't want to mix them up. But 4-pin is there, and we're going to solder it in place. Now the old connector was just too far gone. It had seen much better days, and it wasn't making good contact. Okay, and then that's pin 4. Pin 3 is the green wire in this particular case. That's the right channel. And then pin 2 is the left channel. It's the blue wire in this case. By the way, the wires might be colored a little differently on your unit, but if you followed them from the original connector, you'll have a little chart to go by. And pin 1 is 24 volts, and it's usually red. And we're going to solder that in place. Now, I haven't pop riveted this to the case yet, because we might have some trouble with the board, and we want to make sure that it's not in the case, because it's really hard to work with if it is. Okay, so we've got a connector, and we've got power supply, and we're going to hook it up. And as you can see with the vibrato off, we have 2 lights lit semi-brightly. And we have a problem. One light is lit, and the other one is not lit, so the vibrato is still not working. At this point in time, we have to check for a possible bad transistor in the vibrato as being one of the possibilities. Now this, of course, when you have the vibrato off, goes through the 150 ohm resistors to light the lamps. And when you go this way, the fact that we're not able to blink at all means the vibrato oscillator is not running. So we're going to check we're going to disconnect power first, and then we're going to check 2 transistors. That's this guy right here and this guy right here. They're responsible for the vibrato. Please note that the transistors, which are original to this chassis in this particular board, with the flat side up and the leads towards you, they are ECB, and the ones that we provide as replacements are EBC. So we're going to check this, and the first thing we're going to do is see if it's shorted between E and C, which it is not. There's a reading of several thousand, and these are NPN, so the positive probe is going to go on the base. 609, and that one doesn't appear to have anything. Let's see, this is, let me just make sure we've got contact. 609. Ah, we didn't have contact. Okay, so that transistor's all right. And we'll try the second transistor. And that, either I have no contact or that one is not working. I don't seem to have any reading on that one. That's this particular one here. So what we're going to do is we're going to remove it. And by the way, when you remove vibrato transistors, since one often is damaged and the other one may not be in a sort of a questionable condition, we recommend you replace both of them at the same time, because the waveform is going to be, you want it to be as symmetrical as possible in the case of the vibrato. So we're going to solder suck out the holes first, and let's see now. We're going to go with that lead, which is the collector. Now, if you have some trouble using a solder sucker and the hole doesn't want to clear, you can always add a little solder to it to give the solder sucker an opportunity to build up a better vacuum. There we go. And now we're going to take the other two leads of the transistor. And what we're going to do is we're going to just pick up the leads slightly here. There we go. And then we're going to just pluck it out. Once we have it out of the circuit, things will get a bit of an improvement. And we can check. So that one reads 648, but that one doesn't. So we have a bad transistor. And as I said, we normally would replace both of them simultaneously. And the reason is that the transistors from 40 years ago would tend to have slightly different characteristics than the ones we provide you. This would result in an asymmetrical duty cycle. In other words, the vibrato would spend more time on one bulb than it would on the other. And this is not exactly what we would be looking for in a stereo vibrato. You want them to spend approximately equal time on each other. So we're going to remove the second transistor, even though it's not defective. All right, we've got our replacement transistors, as I said, with the flat side up, and the wire leads towards you. The ones we send you are E, B, C, and the ones that are original to the board would have been E, C, B. So they won't go in quite the same way as they did originally. But these are NPN transistors, so the positive lead goes on the base, and you can see that the collector junction reads 658. It should read anywhere from 4 to 7. Depends a little bit on the temperature, believe it or not. And that one's 660. So that's a good transistor. And then the only other thing you want to do is to check both ways between emitter and collector. And the reason for that is that some transistors can short out and show two diode junctions, but be shorted between emitter and collector. This is the original transistor that we removed, and with the flat side up and the leads towards you, it is E, C, B. So we're going to place the B lead on the positive, and that one there reads 596, and that one reads 609. And then if we go to the other transistor, you see this reads nothing, and that so there's no base connection. It's not shorted. Now I find that interesting, that we do have a junction there, but we don't have a junction between base and collector. Oh well, that one's bad.